Next thing we're going to take a look at is area and volume. The good thing about area and volume is the formulas are provided either in the reference sheet or in the problem that you're going to use, so you don't need to remember any of them. Most of the time, it just involves plugging in the values known for the formula and solving and isolating and solving for any unknown values. And we'll go through a couple different examples with that. So here we have a model of the moon and with a radius of 10 centimeters. What is the volume of the model in cubic centimeters? Well, they tell us that the moon is the shape of a sphere, and so we want to use the sphere formula. So using V equals 4/3 pi r cubed, we're given the radius, and then from there we just go ahead and solve it. Since V is already isolated, there's a couple different ways we could look at our answer. If we simplify this, 10 cubed is 1,000 times 4/3 is 4,000 thirds pi. This is an exact answer. And if we wanted to estimate it, then we could go ahead and in our calculator take 4,000 thirds times pi, and we would get, based on however many digits they want us to round to, something along the lines of 4188.79. And so we would just round appropriately based on the directions for the question. Now the next one will be a little less straightforward. We have a puzzle box shaped like a rectangular prism, and so we can go ahead and grab the formula for a rectangular prism, which is volume equals L, W, and H, length, width, and height. Well, they tell us that they have a volume of 240, so we can substitute that in for volume. It has a length of 10 inches and a width of 8 inches, and we need to solve for the height. And so from here, we just go ahead and we simplify and solve, and we get a value of h that equals 3. Still pretty straightforward, just not as direct. Last one, we have a pyramid with a square base, which is the same as a rectangular pyramid. So we have the formula where the volume equals 1/3 the length times the width times the height. And so we can substitute our values in. We want to find the volume. So the volume will equal 1/3 times the length is given as 8 centimeters. And since it's a pyramid, the width is the same. And then we're told that the height of the pyramid is 2/3 as long as the side. So that means it's going to be 2/3 times the side, which is 8. And then we can just evaluate that as a fraction. We have 1,024/9. And then if we wanted an estimated answer, a couple different ways. We'll notice that it's 113.7 repeating on the 7, which is approximately 113.8. So we just need to pay attention to rounding directions. Now, the next thing that we're going to cover is a little bit more complicated, but once you get the hang of it, you really understand, is changes in dimension. When a linear dimension to the first power is changed by a factor, the area or the volume changes by the same factor. So for example, when we have the area of a cube or of a rectangular prism, where volume is length times width times height. If I double one of these dimensions, such as the length, and now I have 2 times the length, my volume also gets doubled. But if we have something that is raised to the second power, such as the area of a square, which is the side squared. Well, if I change the side and I double the side length, what I'm actually doing is multiplying the whole area by 4 because it's 2 to the 4th power. So it changes by the square of the factor. So let's look at an example here with the cylinder, which has a linear term as well as a squared term. So if we have a cylinder with a radius of 2 and a height of 6, we have an area or a volume of 24 pi. Well, let's look at what happens if we double the height or we triple the height, which is a linear term. Well, the volume equals pi, and then we are taking 2 squared, which is the radius, and then the height, and we're doubling the height. We're multiplying the height by 2. That gives us 48 pi, which is double the original height, or double the original volume. If we triple it, we get 72 pi, which is triple the original volume. And so we see that when we double and triple the linear value, the h, we get double or triple the volume. But if we double or triple the radius, we get something different. If we take the volume and we double the radius and then we square it, multiplied by the original height, we get 96 pi, which is 4 times the original volume. And if we triple it, we get 216 pi, which is 9 times the original volume. So we are getting the square of the factor. And so questions like this, we're looking at which of these will be true, and this one asks us to choose 2 answers. We have a right circular cylinder A with a volume of 64 cubic feet. Which of the following right circular cylinders will have the same volume? And so we have to think about how the changes in dimensions will change the overall volume and see which ones cancel each other out. And so if we take a cylinder with 2 times the radius, well, what we're actually doing is we are increasing the volume by 4 times because the radius is squared. While the height of the cylinder is half, so we're only decreasing it, and it's going to be 2 times less. Well, that still ends up with 2 times a greater volume. So it's not going to be A. 2 times the radius gives us an increase of 4 times as much volume. And 1/4 the height, which is linear, gives us a decrease of 4 times the volume. Well, those cancel each other out. So that means that the volume ends up being the same. But remember, we have to choose 2. So let's take a look at the other options. A cylinder with 1/2 the radius. Well, we square 1/2, and so it's a decrease of 4 times the volume. And 8 times the height, that's linear, so we get 8 times more volume. Well, that still leaves us with an increase of 4 times the volume. And then last but not least, a cylinder with 1/3 the radius. Again, we square that, so it's 9 times less volume. And then 9 times the height will give us 9 times more volume. Those cancel out, giving us our 2 options of B and D. Next, we're given the volume of a right circular cone. What is the volume in cubic inches of the right circular cone with twice the radius and twice the height? Well, if we have twice the radius, again, that's a squared term, which means we're going to have 4 times as much volume. And twice the height, that's linear, so again, that's just going to be 2 times more volume, which gives us a total of 8 times more volume. So all we have to do is take the original volume, multiply it by 8, and we get a new volume of 1,800 cubic inches.